So for today, it's the last day of new stuff, and your assignment is basically to make sure we've learned everything. Then Monday we review, and Tuesday we test. So that's pretty quick. And let's just go through some real basics to make sure that you're on track. But everybody draw a unit circle, just like this. If that's really a unit circle, how long is that radius right there? That's it. 1. Very good. All right. Next thing you'd be expected to know is if it's really a unit circle, and this is 1 and this is 1, and I made that be 1 also, then what is this? That's 1 radian. About how many degrees is it? 1 radian is about how many degrees? 59-ish. It's just not quite 60. If it was 60, it would take exactly 3 of them to get here, and this would be 3 radians. It's not. What is it? 3.14 radians. So that's pi radians. Pi goes with 180. All right, so if I give you a radian, you should be able to find it. Everybody right now on your circle, would you please label the one I said is the most important, pi over 6. 1/6 of the way to pi. Did you make it about a 30-degree angle? Raise your hand if you had that one right. Okay, cool. Would you now put a red mark where 3 pi over 2 is? Draw a red line where 3 pi over 2 is. I always want you to think about where 1 of each thing is. Where's 1 pi over 2? Well, that's here. And then you can count it up. 1 pi over 2, 2 pi over 2, and I said to use red. 3 pi over 2 is that line right there. All right, now I'd like you to tell me what the sine of 3 pi over 2 is. Good luck drawing a triangle on this one. This is not the kind where you can draw a triangle. Robbie, this is a point. It's on the unit circle. It's what, comma, what?
I don't know.
Okay, unit means 1. Think about this. It's a radius of 1. So then to get to that point, I go, 0, -1. Okay, now the sine is a certain letter. Everybody say it after I say sine. Y. All right, sine is y. You got to keep that straight. So if the sine is y, what is the sine of 3 pi over 2? -1. Because it's the y value. It's right there. All right. Next, let's do... you know where 4 pi over 4 would be, wouldn't you? 4 pi over 4? Okay, where's 5 pi over 4? Put a blue line where 5 pi over 4 is. 5 pi over 4. I always encourage people to think, well, where's 1 pi over 4? Even if you know, okay, I know where 4 pi over 4 is. Do you know how big the wedges are? Because, see, this is 1/4 of the way to pi. 1 pi over 4. 2, 3, 4 pi over 4. Now I know how big the wedges are, you know? So then 5 pi over 4 is right there. Now, would you please make me the right triangle that goes with that? Red. No, not red. The blue one. Sorry. Because I want cosine of 5 pi over 4. What is the cosine? All right, well, first you have to have the triangle. That requires you knowing a whole bunch of little things like you have to make the triangle this way. If you didn't, you're doing it wrong. There's no other way to properly make the right triangle. Then you got to know that this is a 45, and then right away you should snap into like, oh yeah, I know this one. It's 45, 45, 90. It's a 1, 1, root 2. But then what's the most common mistake in circle trig? Forgetting a negative. Okay, so now that's also negative. Thank you. Okay, so now if I wanted the cosine, which is what I asked originally, what's the cosine of 5 pi over 4? Cosine is adjacent over hypotenuse. It's that over that. The final answer is negative 1 over root 2. All right. Now, I want you to think for a second. If I had reversed the question and you figured out just now that the cosine of 5 pi over 2 is this, negative 1 over root 2. What if I had reversed the question and said cosine of what? Well, now it'd be easy because you just did it. But then if you just said the answer was 5 pi over 4, you'd be wrong because there's two answers. I'd like everybody to figure out where that other triangle is that would also give you negative 1 over root 2. So I gave you a little acronym. All students take calc. And from that, you're supposed to be able to go, okay, I know cosine's negative in two places. Cosine's positive here and here, but it says cosine is negative 1 over root 2. That means the other triangle must be up here. And since I know what the first triangle looks like, I can kind of just cheat and take the sides off of that. This is a 1, negative 1, and root 2 triangle. And now, really what I want is the angle, though. The angle is 5 pi over 4, and the other angle's this one. And it's 1, 2, 3 pi over 4. And that's the right answer. Raise your hand if you had 3 pi over 4 as your other answer. Cool. Now, let's see if you really got that. What's if sine is 1/2? Sine of something is 1/2. There's two places that happens. So there's two angles that are the answer. Would everybody please draw this situation for me? If I were you, I'd, now that you're good at this, I'd always make a circle. I'd always put ASTC. Because just like every other problem on your test, we're going to be like messing with sine's positive. Oh no, now sine's negative. And so you got to be good at knowing where to go. So Oscar, is sine positive or negative on this one?
Positive.
Sine is positive. So which one should I throw out? Because it can't be there.
The bottom two.
Nope. Oh yeah, no, you're right. Sorry, I was thinking you meant that's where they were. Yes, you should throw out the bottom two. Okay, good. So then the actual answers must be here and here. And just try to draw a generic looking right triangle. Don't make it a really skinny one because you don't want to get confused about which side is small, which side is big. And sometimes people label them wrong and then they get all confused. So sine is opposite over hypotenuse, 1, 2, and that's got to be square root of 3. From this angle's perspective, opposite hypotenuse, except this one's negative. And now I've got my triangles drawn. So what are the answers? This angle right here was 30. Could I say 30 on the test? Nope. Your answers all have to be radians on the test. So what would the right answer for that be then? If it's not 30, what is it? Pi over 6. And then everybody figure out the other answer. Yes?
How do you know it's a 30/60/90?
How do I know it's a 30/60/90? Because the sides were 1 and 2, and if you use the Pythagorean theorem, or you just have this memorized, it's got to be the square root of 3. How do I know the sides were 1 and 2? Because it had a 1 and a 2 in the problem. Then the third side had to be the square root of 3, and that meant it had to be the 30/60/90 triangle. And this side had to be 30 because it was across from the, with a 1. So that meant that had to be 30, which makes it pi over 6. And if that's pi over 6, then what's this one? Well, it's a whole bunch of pi over 6s. Tyler? 5 pi over 6s. So this spot here is 5 pi over 6. Two answers. Pi over 6, 5 pi over 6. Any questions on that one? How many feel like you get that one right on the test? You got this. Okay. Well, you still have another day to get smarter on Monday, too, for those of you that aren't raising your hand yet. All right. This time, I'm going to narrow it down. You know how each time there's been two answers? This time, I'm going to give you a little more info, And then your answer will only be one of the two possible answers. Cosine of some angle is negative 1/2. Now you could go find me the two answers, but don't, because tangent of that same angle is less than 0. Now, only one of the two places that you could have drawn this triangle will work. I'll pause for a sec while you give that a try. So I hope that gave you some time to get this figured out. First of all, I honestly, every single time, I would put A, S, T, C. Get used to it. It really, really helps. Where is tangent negative? Because see, it says tangent is less than 0. So it can't be here and it can't be here. So then you had to draw your two triangles here and here. No, I'm wrong. Why? Because cosine has to be negative. That means it can't be here. So now I'm down to just one triangle to draw, that blue one. I'll make it dark black here, and I'll say adjacent, hypotenuse, 1, 2 square root of 3. And oh, this is such a common mistake right here. People go, it's the 30, 60, 90, so the 30's right here. Wrong. What's actually right there? 60. Remember, the 30's across from the 1, so the 30's up there. This is a 60. And then the next common mistake is, so people go, the answer's 60 degrees. No, it's not. It's 60 degrees is over there. This isn't 60 degrees. It's all of that, which is something minus 60. So let me think, it'd be 120. And that'd be another mistake. If you write 120 on the test, I got to cry a little bit and mark it wrong, because it's supposed to be radians. If it's 120, that is 4 30s. Why am I saying that? Because 30s are pi over 6s. 4 pi over 6. I probably would have taken it because it's so close. Really should have said 2 pi over 3. Who had 2 pi over 3? Nice. Do you see how many chances there were to screw up? It's like I could have easily said 30 because I saw it as a 30, 60, 90, and that leads with the number 30. I could have easily thought about like just leaving my answer in degrees. Anyway, all right. Yesterday we had one like this. Sine of some angle is 7/8. Now on this kind of problem, we will never ask you for the angle because you won't have a calculator on this test. You may have noticed we haven't been grabbing the calcs to do stuff, okay? Because if I needed the answer for this on a calculator, it'd be easy. I'd just go inverse sine of 7/8, I'm done. But what we would ask you is to draw the triangle that has this scenario and then figure out cosine of the angle. Give this a shot. If sine of theta is 7/8, what's cosine of theta? Again, once you got a picture with all the sides on the triangle, it's going to be easy. So to draw it, and I know some of you are thinking, but there's two places that could be, Mr. Server. That is a valid point. So why don't I say, they always told you, do you remember these questions? They always told you, in quadrant 1, okay, but I'm going to give you my clue in a different way. Sine of theta is 7/8. And cosine of theta, no, I'd already told, I'm going to ask you for cosine, so my bad. I got to change that to tangent. Tangent of theta is negative. So I'm going to say less than 0. Now, there's only one place where you can safely draw that triangle where the sine is positive and the tangent is negative. There's only going to be one place where that's the case. And once you got the triangle drawn, just asking cosine of it. All right, I want to kind of give you a fair warning. The test, I really kind of, my dream world, we'd test Wednesday, but we can't. So, the test is Tuesday. So, There's only one last thing to teach you today, but bottom line, if you haven't been doing your homework, you gotta get into it now and get into it this weekend. Because I think I've mentioned this to you before. If you can do well on this test the first time, you will save yourself a 3-hour retake process. I guarantee you, you're gonna wanna retake this test if you bomb it, because there's so much based on it. So if you can save yourself 3 hours, maybe it's worth doing an extra 15 minutes here and there, getting ready for this test. All right, this is the part where I'd like you to compare where your triangle is. It's in quadrant 1, 2, 3, or 4. And if you're not sure, maybe the person next to you can help. These two rows, compare straight across. These two rows, compare straight across. You two, compare long distance here. You two.
And then what you get less is in the one. Exactly.
All right. Now, sine's positive, and my first instinct would have been to draw it here, but what stops me from doing that? Why can't I do that? Because tangent's negative. And tangent wouldn't be negative. All of them are positive there. So I go to ASTC again. That's why I say I'd always put it down if I were you. And I go and say, where's tangent negative? Well, it's not negative here, and it's not negative here. And where is sine positive and tangent's negative? And I end up narrowing it down to right there. And now I can put in my sides. Sine is opposite and hypotenuse, and that's like a 7 and that's like an 8. And I don't know the third side. Do I need to know the third side? Yeah, I do, because I can't figure out cosine without it. So then, learn my shortcut. Let me tell you, you do not want to be going a squared plus b squared equals c squared and solving. Look at how fast this is. Square root of 64 and 49. And am I on the longest side? If so, I would add. I'm not, so I subtract. See how fast that is? You guys do that? You good at that? All right. So Jacob, what was that third side?
Square root of 15.
Louder?
Square root of 15.
Correct. All right. And by the way, if you can simplify those, you should, but root 5 and root 3 aren't any simpler. But if it was like square root of 8, you'd want to simplify it down to like square root of 4 and the square root of 2, which would be 2 root 2. So simplify those if necessary. And the last thing is the actual answer, Jack Taddy. What is the cosine of that angle? This key angle right there.
Oh, it's negative.
Oh, it's negative root 15. Thank you for catching that. Most common mistake in circle trig. Now I have about the answer.
Negative square root 15.
Negative root 15 over 8. That's it. Nice job. These are getting pretty weird, aren't they? I mean, look at that answer. Negative square root of a number that never ends over 8. Jeez. What even is that? Well, it's a circle trig question. All right. Now, are you going to see these in your daily life? Well, it depends what your job's going to be. We're starting to get into complicated enough math that if you're going to be an engineer, yeah, you're going to see trig. You're still going to see trig, for sure. And you're not going to run into this on a daily basis if you're not in a more high-tech job. Okay. So what's really new for today, Mr. Server? All right, I'd like to do a nice, simple, let's just do the classic 30, 60, 90 triangle like this. And then we all know the side ratios. If this is really a 30, 60, 90, then this is a 1, 2, and this is a square root of 3, right? Okay. Then, the key angle theta is going to be the 30. What is sine of the key angle? I'm just going to write theta just because it's a lot faster than writing 30 for how many times I'm going to have to do this. Sine is opposite over hypotenuse, so that's 1/2. What's cosine of the angle? Say it. Square root of 3 over 2. And what is tangent of the angle? You might be like, what's the catch? This is too easy. The catch is we're going to learn the other 3. Tangent, TOA, opposite over adjacent, 1 over root 3. Do you get that in some worlds they would say root 3 over 3? And it's the same thing? You You're sometimes going to see that on tests. You're sometimes going to see that in the ACT where they won't leave square roots in the denominator. So they'll do this, which is really multiplying by root 3 over root 3. That's supposed to be a 3 on the bottom. Okay, then here's my question. What are the other three functions? And does anybody already, usually this is like one kid who's heard of these and knows which one goes with which one. Sine has a sister function. It's its reciprocal, and it's called something. Good guess, but no. Secant is one of them. You had a 1 in 3 chance. Yes?
Like SEC.
Nope, that's the SEC stands for secant, but no, that's not the sister function of sine. Sine and secant are not related. Yes. It is. It's CSC. Cosecant of theta. CSC is not the real word. Cosecant is the real word. But we're never even ask you to spell it all the way out. You'll just use CSC. And what is the answer? I said it was a reciprocal, so what's the answer? 2 over 1. I'm just going to put the over 1 to show people where it came from. But absolutely, 2 is the same answer. All right. Now, a lot of you suggested secant. That's the secant goes here. It's the sister function from cosine. And so 2 over square root 3. Notice it's just a flip. And last is tangent. Anybody? There's only one left. Say it if you know it. Cotangent. Now, if you haven't put this together yet, there's sine and there's cosine. There's secant and there's cosecant. And there's tangent and there's cotangent. But they aren't flips of each other. Like, it's not as simple as the word and the co-word are the ones that are across from each other. But there is this little pattern. S goes with C, and C goes with S. And don't tangent and cotangent just seem like they go together? Yeah, but the other two are kind of like goofy. Okay, so cotangent is just a flip. And I'm going to take the original one I had and flip that, root 3 over 1, which of course means root 3. Now, if sine, cosine, and tangent are defined as SOHCAHTOA, these would be CHO-SHA. Cow. But the problem with that, if you were going to try to remember it as, you know, like a snappy saying, like SOHCAHTOA, is that you can't tell in CHO-SHA-COW whether you've got a C, you know, in the CHO, and you've got a C in the cow. So, anyway, bottom line, don't try to memorize it that way. I'm just saying that to kind of be dumb. I would just memorize which one is the flip of sine, which one's the flip of cosine, and which one's the flip of tangent. All right, so when would you ever see this? Well, just like we always gave you problems like find the sine of 5 pi over 6, now we could say find the cosecant of 5 pi over 6. And then here's what I would do if I were you. Cosecant of 5 pi over 6. I would go, nope. I would peacefully resist and say, I'm not doing cosecant of 5 pi over 6, Mr. Server. What I will do is I will do sine of 5 pi over 6 because it's the sister function. And then I will flip it. Okay? So don't even try to do cosecant right off the bat. Realize that cosecant is the sister function of sine, and so you're really going to be doing sine of 5 pi over 6 and then flip it. Obviously, it's important to flip it at the end or you're just doing sine. All right, so here's where 5 pi over 6 is. By now, I'm hoping those are coming pretty quick for you. And then I draw my little triangle. And then I know it's a 30, 60, 90 because it's pi over 6 or 30. So that's got to be a 30. And then this has got to be a 1. 2 square root of 3. Careful of the most common mistake in circle trig, the negative right there. And then I just do sine of 5 pi over 6, but I would always, if I were you, put 1 over it to remind yourself, you haven't done it really until you flipped it. So what is sine of 5 pi over 6? Well, it's opposite of hypotenuse. It's 1/2. So then what do I got to do to finish the deal? It's not 1/2. What is it?
2.
It's 2. I got to flip it. So there's my answer. Yes?
So, with the finding the sine of 5 pi over 6, once you draw the triangle, why would it be like sine of 30 instead of like sine of,
All right, remember how 5 pi over 6 is this angle? Remember how that's like 150 degrees? You can't really draw a right triangle with a 150 degree angle in it. So when you're asked to find the sine of 150, which is really what I just did there, because then you find the sine and then you're going to flip it. To find the sine of 150, you have to use this as what's called a reference angle. It stands in the stead of the 150. So if you find the sine of that angle, that's what you're looking for. Okay, this is called a reference angle because you refer to it when you're doing this problem. Otherwise, if you would like, try to draw a right triangle that has a 150 degree angle in it and do it that way, because you can't. All right, so I think we've covered it all. So now we're just going to fly through the notes quick to make sure that you understand what you're supposed to know by now. Are we going to test you on the unit circle? No, we are not going to make you memorize and write out all of this. But would we ask you to find one of them by giving you a problem? Yes. So let me give you an example of that. Let's say that I said, I want this one right there. Could you make a right triangle out of it? Could you figure out if it's a 30, 60, 90 triangle? Is it a 30, 60, 90 triangle? Yeah, it is. Could you then figure out its sides, and could you then eventually get these 2 points? The things that make the and where would you get those from? It'd be this side, the red side, and it'd be this black side. I'd like you to do that right now to make sure you don't get confused and think. I bet some people are going to forget a key step. Okay, so let's try it and let's see who would have gotten this one wrong. Pausing. So by now you should have known that this was a 60. Just look at it. It's way too big to be a 30. And this is the 30. And that makes this side a 1 and a 2 and a square root of 3. You got to get good at that. If you by accident reverse the 2 and the 3, a lot of kids do that, and to their peril. Then you got to remember that you got to divide everything by 2. Did you remember that key step? Why? Because it's the unit circle, and the radius has to be 1. Okay, so now, most common mistake in circle trig, that's got to be negative. So my x is negative 1/2. And my y, my height, is root 3 over 2. And now what's sine? It's the y. What's cosine? It's the x. What's tangent? It's the y divided by the x, which is a fraction divided by a fraction, which is why it's on the top 20. Okay. Any questions? Raise your hand if you had a question. Okay. Then, we could bounce that answer over to this one, and it'd be the same numbers, except they're just different negatives. It would be the same exact numbers. And this would be the same exact numbers, and this would be the same exact numbers. Just different negatives. Okay, moving on. I think we've done enough of these that I just want to do one. Would everybody it should be fast by now. What's sine 11 pi over 6? It should be like your happy place. If you weren't drawing it here, you're messing things up. That's 11 pi over 6. Sine is opposite over hypotenuse. Wait a minute. This is 30. So 1, 2, square root of 3. There we go. And it's not the unit circle. I never said it was a unit circle. Oh, wait. It says unit circle. But does that really change what the sine answer is going to be? Just to clarify, it does not change what the sine would be. Sine is opposite over hypotenuse, and most common mistake in circle trig, right there, -1/2. And if you're like, but you didn't make the radius 1. Okay, I'll divide everything by 2, and then guess what happens? It's sine is opposite over hypotenuse, right? So here's the opposite, and it's -1/2 again. Okay. We did one of these already. Yeah, I think we should do one. Do it quick. Quadrant 4, draw the triangle. Once you get the triangle all drawn, does anybody remember the triangle that goes with? That'll be able to help people save some time. Jacob.
7, 24, 25.
7, 24, 25 triangle. Okay, I made up a couple sides, 1 and 2, and you were smart enough to figure out that this is the square root of 3. At least I hope you were. You probably even know what the angle is, but I didn't ask for the angle. All I asked for is sine of the angle, tangent of the angle. Let's do sine of it. Opposite over hypotenuse. There's opposite. There's hypotenuse, √3/2. And immediately I know this one, 2/√3. They're just a flip. And then tangent, TOA, opposite over adjacent, √3/1. And I put the over 1 just because it's easier to flip it then. 1/√3. And there we go. Any questions on that one? That was the main new thing for today, so I think we're in good shape. This is just definitions. And the main thing they include in definitions when you're really being careful is that cosine can't be 0, because why? Because you can't have 1/0, right? So they're saying cosine can't be 0. The answer to it can't be 0, or if so, secant just doesn't work. Secant will be undefined. All right. Tangent is sine over cosine. Remember that? If you're like, I don't remember that, it's y/x. And sine is y and cosine is x. Cotangent is just a flip of tangent, so that shouldn't be a surprise that those flip over then too. Okay, you've made it to the end. Congratulations. I know that was a dense, heavy-duty learning day, but we have covered pretty much everything you would ever need for the test. We will review it again on Monday. Test is Tuesday. Strongly recommend some practice tonight. Telling you, most important test of the second semester on Tuesday. Okay, that's all I got for you for today.